Right, folks. Okay, this is another 5-minute short lecture on this time on a little bit on data preparation, just a few key things on data preparation, and then we'll go on to vshale and lithology. But first of all, regarding data preparation, the first thing is to collect all your data. You must. This is the main part of the evaluation now, where you're doing a proper integrated study, and you have to collect. It's very boring, but you must collect all the data and get a good idea of what you've got, and you must document it and look at it and think about what you've got and plan your evaluation based on what you've got, and data hierarchy, as I've already explained. And so you must prepare all your data and put in a big grid, a big table where you can see all the wells and all the bits of data you've got for the different wells. And that's important reference for you, both for you to think when you're later on in your evaluation, you're doing something complicated. You'll go back and you'll need to refer to that table and say, I've got a bit of this information in this well. Can I use it for this evaluation? So the table is quite a useful little thing for a quick reference table. And of course, for your reviewers who are building the geological model and they want to know what this results that you've given them are based on. And if they look at your table of input data, they will see what you had available to you for the evaluation. Hopefully you've used it in the most efficient manner, because that's what this course is really all about. This course is really all about, here's the data we have, now let's use it in the most efficient, the most richest way we can screw all the information out of this limited data that we've got. Okay, so you make a big table, and another important, I'm not including all the things in data preparation here, but another quite useful and quite simple thing to do is a depth match. You need to set up in each well, your base log, which is often the first gamma ray run in the hole. Sometimes people like to use the density log because that's a very important log for everything. Either the first gamma ray run in the hole or the density log. I suggest you use it the same in every well, whatever you choose. And then you depth match everything on about a 2-foot basis. 2 foot, you need to get it as close point-to-point depth matching all the way down the well. Sometimes this can be quite confusing, and I suggest to you, if it is confusing, first of all you go and you pick the major, or get the geologist to pick the major intervals in the well, and then you tie the depth, the inflection points of the logs at that interface, the inflection points, which is where the logs are showing a maximum rate of change between between formation 1 and formation 2. The value changes. The inflection point is where supposedly where the boundary actually is. That's the depth reference point. And you can fix normally a few of those in the well, and then between them, those points are then fixed. You can then depth match more easily between them. Okay, so prepare your data, make a big table, do the depth matching, and the final important thing about data preparation is, in older wells, you need to do log normalization. Now, log normalization means, in a nutshell, that in different wells, the same named curve will give you the same value for the same actual rock properties. If you've got the same rock properties in different wells, this same named curve, let's say row B, will always read 2.31 in this well, in this well, in this well, in this well. And that's obviously in order to do a consistent field well evaluation where you can have cross calibration between different wells. Okay, so you've got some core data in one well and you use that to calibrate that well, and then you use that same relationship between logs and core in other wells. Of course, you have to have the same relationship between the log data and the formation in all the wells, don't you? Otherwise you can't use that one well calibration in the other wells. So in that sense, log normalization is important, particularly with older data. In modern wells, after about, say, I don't know, difficult to say, after 2000 certainly, most logs don't really need normalizing, but sometimes they do. In older wells, where you may have some important core data, so you may have to include those wells. You may think, I'm not going to put that well in, it's a bad data, old data. But if you've got core in that well, then of course you have to include it, because core data is probably going to be the best hard information you get about the rock that you're trying to find out about. Okay, so what I'm going to switch over now to my slides, and you will see here is an example. of log normalization. So the point that I want to make about this is that you must use 2 parameters, not 1. Okay, don't use histograms where you've got 1 parameter from all different wells, say row B, you put it onto a histogram, and you make a histogram where you've got all the different, histograms of the different wells of that 1 parameter. Because of course different wells might have different values for that parameter. Nature varies, right? The key, so what I like to do is to use cross plots where you compare 2 highly correlated parameters like rho B and delta T, or rho B and resistivity, as long as you're within 1 fluid zone, and then see if most of the wells will line up along that trend, right? And that means the data is probably good. Okay, it might be offset up and down that trend line. One well might be more porous than another well, for example, but they are on the same trend line, so therefore the data, even though one well is more porous than the other well, they still appear to be, the data seems to be valid. If you find one well where the trend is not the same between these 2 highly correlated curves, then we begin to think, well, it looks like all the other wells have had this pretty clear trend. This one looks odd. Is there something wrong with the data? And there may well be. You can then correlate these 2 with another curve, maybe neutron or something, and that might help you to determine which of these 2 is off or whatever. Okay, so the key point about about log normalization is don't use histograms. Use 2 curves to establish a trend between those 2 curves, and then you will be aware of when that trend is being violated by some bad data. That's all I want to say about data preparation. We'll move on now to vClay and lithology. Now this is only a 5-minute chunk, so I'm just going to summarize, well, not even summarize really, I'm going to miss out a lot of stuff which you would get if you were on the proper course. This is just little bits and pieces that are outside the main VILT part of the course, which is only incidentally about 50 to 60% of the whole content of the course.